Hey there, grade 9 students of St. Paul American School, Clark. Okay, let's jump right into this explainer on mastering the measurements of circles. Today we're focusing on Unit 7, Lesson 3, Circumference, Arc Length, and Sector Area. Whether you're totally new to these geometry concepts or you're just looking to sharpen up your existing skills, you are absolutely in the right place. We're going to make all of this incredibly clear, structured, and super easy to apply. Here is our roadmap for today. We'll hit our objective, dive into the explanation, tackle some worked examples, do a quick misconception check, a formative check, and finally, wrap it all up with a recap. All right, part 1, objective. Let's make sure we truly understand our circle parts. Let's start right at the foundation. The circumference is the full, complete boundary of the circle. Imagine you're walking all the way around the edge of a perfectly circular park. That total distance you walked, that's your circumference. Now, this measurement is heavily reliant on the radius, which we usually just call r. That's the straight line distance from the dead center of the circle out to any point on that outer edge. So our formula here is c equals 2 times pi times the radius. But what if you don't really want to walk around the entire park? Well, that's where our next term comes in. Think of arc length as just the pizza crust. It's merely a specific fraction of that total circumference we just talked about. Basically, it's the distance along the curved line that forms a specific arc. You aren't calculating the whole circle's edge, just one piece of it. Building on that exact same analogy, if the arc length is just the crust on the outer edge, the sector area is the entire pizza slice. It's a two-dimensional region bounded by two straight radii and the curved arc that connects them. So it represents a specific fraction of the total internal area of the circle. Moving on to part 2, explanation, digging a bit deeper into arcs and sectors. Now, what's genuinely brilliant here is the part-to-whole framing. For arc length, you literally just take your central angle, theta, divide it by 360 degrees to find out exactly what fraction of the circle you're dealing with, and then multiply that fraction by the full circumference formula, 2 times pi times r. And for sector area, you do the exact same thing, but you multiply that same fraction by the full area formula, pi times r squared. It's incredibly logical when you think about it. Oh, and for radians, which honestly are even simpler, arc length is just radius times theta, and sector area is 1/2 radius squared times theta. To actually apply these formulas without getting tripped up, I want you to follow this 4-step strategy every single time. 1. Identify your given parameters. Just find your radius and your central angle. 2. Look closely to figure out if that angle is measured in degrees or radians. 3. Carefully apply the correct formula based on those units. And 4. Always check your unit consistency. Are we dealing with inches, feet, centimeters? Just make sure your final answer uses the right units. Okay, part 3, worked examples. Let's take this step by step. Here we have a classic arc length problem. Step 1, we identify our radius as 11 feet and our central angle as 315 degrees. Step 2, because it's 315 degrees, we immediately know we're going to use our degree formula, which involves setting up that fraction over 360. Step 3, we apply it. We set up our fraction, 315 over 360. Then we multiply that by 2 times pi times our radius of 11. If you plug that whole shebang into your calculator, you get an arc length of 60.47, which will round up nicely to the nearest tenth, giving us exactly 60.5 feet. And step 4 is good to go because our unit, feet, matches the original radius unit perfectly. Let's try another one, but this time let's calculate the sector area. Remember, that's the whole pizza slice. Our parameters are clearly defined. Our radius is 10 inches and our central angle is 60 degrees. So the crucial point here is to make sure we use the area formula. We take our part-to-whole fraction, 60 over 360, which simplifies really nicely to 1/6, and we multiply it by pi times our radius squared. That's pi times 10 squared, or 100 times pi. 1/6 of 100 pi gives us a sector area of 52.359. Rounded to the nearest tenth, that is exactly 52.4. And notice the units. It's square inches, because we are measuring area. Part 4, misconception check. Let's look at some common mistakes. Let's be real. It's easy to make a small error here. The absolute most frequent mistake students make is simply forgetting to square the radius when calculating sector area. You get so hyper-focused on the fraction that you just multiply by r instead of r squared. Another massive trap is accidentally using the radian formula when you're given a degree measure, or, swapping the formulas entirely and finding the crust when the question specifically asked for the whole slice. Always double-check your formula before you start crunching the numbers. Section 5, Formative Check. Now it's your turn. I'm going to give you a quick scenario. Remember your 4 steps. Identify your parameters, choose the correct degree or radian formula, apply it, and check your units. Are you calculating a distance or an area? Let's find out. Your radius is 13 feet, and your major central angle here is 270 degrees. What is the arc length of that heavily bolded outer curve? Take a second. Think about setting up your fraction. 270 over 360 times 2 times pi times 13. Okay, if you got 61.3 feet, great job. You successfully applied the part-to-whole arc length formula. You essentially multiplied the fraction 270 over 360, which reduces down to 3/4, by the full circumference of 26 pi. The unrounded calculation is 61.26, which rounds perfectly to 61.3 feet. Excellent work. Finally, part 6, recap. The formulas you absolutely need to remember. As this tip points out, a little memorization goes a long way here. Remembering that arc length relates strictly to the circumference, the outer boundary, and that sector area relates to the whole area, the space inside, will give you a massive advantage. It's really all about that part-to-whole relationship, your angle over 360. By breaking down these definitions, really understanding the part-to-whole formulas, and rigorously applying our 4-step method, you've got everything you need. So the next time you look at circular geometry out in the real world, whether it's a car wheel, a pizza slice, or a radar screen, ask yourself, are you looking at the crust or are you looking at the whole slice? Master the circle and you master the geometry. But let me leave you with a quick puzzle. If you only knew the arc length and the sector area, could you work backward to figure out the radius? Keep that floating in your mind as you continue your grade 9 math journey. Thanks for hanging out with me for this explainer, and keep up the great work.